Right, so in our previous question, we have calculated the angles, and I just saw that I was working a bit too fast. So our initial domain was between 90 degrees and minus 90 degrees, okay? So basically, one of our angles then has to be negative, okay? One has to be negative. So we were supposed then to have a bracket here in order to bring out that negative. Okay, so at the end of the day, we are going to have an angle of negative 54. So the solutions to that, x is supposed to be 35.8 degrees and x is supposed to be minus 54.2 degrees. That is the solution to that particular question. Okay, so that takes me to the next one, question 4. You have a diagram here. The diagram shows triangle ABC where AB is equal to 5, AC is equal to 4, and BC equals to 3 centimeters respectively. 3 circles with centers at A and B and C have radii 3 centimeters, 2 centimeters, and 1 centimeters. Right, so our objective is the circles they touch each other, as you can see at the various points as indicated, and AB, AC, and BC, they are lying, those points are lying on those lines. We're supposed to find the area of the shaded part. Now, don't assume for now that this triangle is a right angle triangle, although it is one. Okay, so I would perhaps say maybe if I draw triangle ABC, so let me just explain what my approach here is going to be. So I'm going to find the sector angles for each. I'm going to find sector A or EAF, sector EBG, FCG. I'm going to find those angles, and I'm going to calculate the area of those three sectors. And then I'm going to calculate the area of the triangle, and I'm going to take the area of the triangle minus the sum of the area of the three sectors. And that's going to give me my shaded part. Okay. Right, so let us just bring in my right angle triangle again, as it's here. So it's not drawn to scale, so that was 5. Let's suppose that was 4, and let's suppose that's 3. Let's just have triangle. Okay. So just take a small break from there. We have some technical issues. Again, it's not a big deal. You can always come back and start over. Okay, so let's restore and let's go back to our work. Right, I wanted to remove these measurements for now. I want to see. All right, so we have got ABC. So this is A. Let's see where B is. BC. And AB is 5. So that's 5, that's 4, that's 3. Okay. Right, I hope you still remember from if you have a scaling triangle or so, how are you going to find the angle? You'll say cos A, for example, is equal to, in this particular case, you take whatever surrounds it, you say B square plus C square minus A square all over 2BC. So in this case, if I have to do the cosine of angle BAC, that's going to be 5 squared plus 4 squared minus 3 squared over 2 times 5 times 4. And then angle BAC will equal to the inverse angle of whatever I'm going to get if I punch that on my calculator. So doing that, that's 5 squared plus 4 squared minus 3 squared over 5 times 4 is 20 over 40. So that gives me 4 over 5. So 4 over 5. Alright, so if you now take the inverse cosine of that answer, you get 36.869. So it is 36.869, and so it continues. So that angle there will be 36.87. All right. Then just want to make sure I got that angle correctly. 869. Right. Then we can also find angle ACB or angle ABC. Just going to change. So the cosine of angle ABC, this is this angle here, it's going to be 5 squared plus 3 squared minus 4 squared over 2 times 5 times 3. Okay, well, we can punch that in. Then we are going to have, in brackets, we're going to have 5 squared plus 3 squared minus 4 squared over 15 times 2, which is 30, over 3 over 5. That gives you 3 over 5. So angle ABC will be the inverse cosine of 3 over 5, which happens to be what? Let us see. So the inverse cos of 3 over 5 happens to be 53.13. Okay, are we really getting 53.13? Okay, so it's 53.13 degrees. All right, you can find the missing one by adding and subtracting from 180, or let's find the cosine of ACB. Okay, so let's use our cosine rule. So we're going to say cos of ACB will be equal to ACB, so we are talking about this particular angle, so it is 4 squared plus 3 squared minus 5 squared over 2 times 4 times 5. Okay, right, let's punch it in and see what we get. So we're gonna have in brackets 4 squared plus 3 squared minus 5 squared, upon 2 times 20, which give us 0. And if you have to work and realize that if you want to find the cosine of angle ACB, which is 0, you're going to see that it's equal to 90 degrees. Okay, if you were to work it out. Okay, of course, you will be saying that ACB, clearly, you'll be saying, if you want to be diplomatic about it, you're going to say angle ACB equals to the inverse cosine of 0, and angle ACB is nothing but 90 degrees. Okay, hence you have got that triangle, that is a right angle triangle. Now, what else do I need to know? I need to calculate the area of the triangle. So I have a 3, 4, 5 triangle. So the area of a triangle. So you have, you have a triangle like so. This is 5, this is 4, that's 3. The area of this triangle, you're gonna say, just want to get my equipment right here. Okay, area of this triangle is nothing but A equals to so we have to quickly check which angle are we going to use. So I'm going to use angle ABC, angle ABC, so that's ABC. So that's angle ABC. So we know this is something like 43.13. So you'll be saying in order to calculate what that angle would be, you're going to say that angle is going to be the cos of 53.13 equals cos of 53 equals 4. Now it's very important that you don't forget how to, in fact we are calculating the area, so let's just correct it. When we calculate the area we're going to use this formula, a half times AB times the sine of C. So the area here will be a half times, we have got 5 times 3, and we're going to multiply that by the sine of 53.13. So all of this becomes calculator work, and you can actually calculate out what that would be. So let's see. So it is 15 divided by 2 times the sine of 53.13. Okay, close it, and then you get the answer. All right, so the area is about 6. I'm just going to write 6 square centimeters. Now we know what the area is. So the area of the shaded part, so the shaded region would be 6 centimeters square minus. Now we're going to take all the other ones that we have, but we don't really have the area yet of the other ones. We know what angle A is. Angle A is angle A BC. Angle ABCB is 53.13. So this is 53. This is 90 degrees. Angle A right up there, we have calculated that angle to be 36.87. So that is where we're at. That is 36.87. So we can actually find the area of the sector. So the area of a sector is calculated by taking the area of a circle, which is pi r squared. We say the area of a circle, which is pi r squared, multiplied by whatever the angle over 360, because it's not yet a complete circle. All right, so the area of sector, this area here of sector, I'm going to write it here, area of sector AF AEF is equal to 36.87 over 360 times pi, and the radius there happens to be 3 squared. Okay, grab the calculator in advance. Where are we at? So you say 36.87 over 360 times pi times 3 squared. 2.896. So that's 2.896. So that is the area of that sector. Another sector, the area of this one here will be the area of sector EBC or CBE. Well, that is CBE, 53.13 over 360 times pi, and what is the radius? The radius is 2 squared. Okay, so ultimately this is also going to give us another answer. So we're going to have in brackets 53.13 multiplied by 360 times 4 pi. 1.854. So this is 1.854. One more, area of sector FCG is equal to 90 degrees over 360. Multiply that, okay? So you have looking for this sector, multiply that by pi r square. So when you multiply this by pi r square, and the r happens to be 1 in this particular case. So that is nothing but 1/4 times pi, which is 4 times 1/4 pi, or we can simply say pi times 1/4. So let's clean this up. Okay, 1/4 pi times, this is multiplied by pi r square, which is nothing else but pi. We are looking for FCG, FCE, FCG, FCG. So that's 90 degrees. So you are going to say 90 degrees if you want to find the area. Just clean that so that we can get together and calculate that. So this answer here, this answer can be worked out, right? So the answer is pi square over 4. So in order for us to find the area of the shaded part, and we can easily find the shaded part by adding all the areas that we calculated, minus 6. So one of the area, if I'm not mistaken, is 1.854. So we're going to have 1.854 here, plus the other two areas that we need to consider. Pi square over 4. Okay, and that is pi square over 4. I just want to see if the pi is really squared. Okay. Next thing that we need to do is we need to find the third measurement. So we have the one measurement. The third one is we have the 36.869. The other area here is 1.854 and 2.896. 2.896. Okay, plus 2.896. Okay, so let's just go back. We have got area of one, area of the other one. So if we break our calculator up, so it's going to be 6 minus 1.854 minus plus 2.896 plus. I just want to see if we can get to the same answer. Well, the radius here is 1, so it will just be pi over 4. Okay. So let's remove that square. Let's grab our calculator. So it's 6 minus in bracket 1.854 plus 504 plus 0.464. 6 and so on and so on. So this answer is square centimeters. Okay, took some time, but we managed to finish that question.